Okay, at this point you should have watched the Khan Academy video. He gives a good development of where the trapezoid rule comes from, why the formula is what it is. I wanted to show you a couple of additional observations related to it. So if we take the example from the textbook, not the example from the video, the Khan Academy video, but if we take the example from the textbook, in which we divided into 3 subintervals, our formula would look something like this. Okay, and I want you to notice that I can write this if I wanted to. The part inside the brackets, I could write that as f of x0 plus f of x1 plus another f of x1 plus f of x2 plus another f of x2 plus f of x3. And again, the whole thing is being multiplied by delta x, and we don't want to forget the 1/2. Okay, why did I write it this way? Well, an interesting thing to observe is that I have f of x0, f of x1, and f of x2, which I could put here as long as I'm multiplying it with the delta x and the 1/2. And then I have f of x1, f of x2, and f of x3, which are here. And those should actually be familiar. It turns out that what I underlined in green here is L3, and what I underlined in yellow here is R3, which means that the average of L3 and R3 is actually T3. And that's what they're talking about in this formula right here. Kind of cool, huh? So let's remind ourselves, whoa, still getting used to this program. Sorry, bear with me. Certain things stick to each other that I don't want to stick to each other. Okay, well, these videos are going to be messy at first. I'll get better at it. Let's look at the trapezoidal rule. All right, so the trapezoidal approximation T sub n of the definite integral from a to b of f of x dx using n subintervals is given by this rule here. Okay, and notice the way they wrote it here, they didn't put a 2 in front of the f of x1, they just kind of wrote it twice, and they made sure that they had these separate terms with a 1/2 in front. They actually wrote out the formula of what it would be to have the trapezoid. Each trapezoid's area formula written out in the formula. And if you wanted to look at it in summation notation, this would be what that is. And then it's also including that observation we made about how the trapezoidal rule is the left approximation plus the right approximation divided by 2. In other words, it's the average of the left and right approximations. Okay. All right. So in this activity, I'm going to have you pause the video after I go over this activity to kind of help you out. I'm going to ask you to pause and try it yourself. So let's talk about this activity before you pause. It's asking you to use the first fundamental theorem of calculus to calculate some integral. Then it says use appropriate computing technology. So what does that mean? That means something like Wolfram Alpha or any of the other computer algebra systems that were mentioned in section 5.5 to calculate these approximations, T4, M4, T8, M8. Okay, and remember that the error is the approximation minus the actual value, because we wanted, if this is positive, it should reflect that the approximation is an overestimate. And if it's negative, it should reflect that the approximation is an underestimate. So you're going to do each of the errors. This is the notation they use for the error for trapezoid, error for midpoint. Okay, and then they ask you some questions about it. All right, so pause the video, give this activity a try, and again, remember, think of questions you want to bring to class.